Exponential growth and decay. Okay, first thing we need to do is copy down some formulas. The exponential growth function is y equals a parentheses 1 plus r parentheses to the t. The decay function is the same thing except there's a minus sign. The way you can remember these is growth you need to add on, decaying you're subtracting. So that's just the difference between the two. A stands for initial amount. That's just how much you start with. So maybe you have an initial population, or maybe you start with $8,000. Whatever it is, that's your initial amount, and it goes right in there for A. Next, R is your rate. So this is your rate. It's either going to be a growth rate or a decay rate, depending on if you're growing or decaying. This is most always given to you as a percent, but you have to change it to a decimal. On the next slide, we'll look at how to do that. T stands for time. So over how many years or how many days or minutes are you growing or decaying? That's what you're going to put in for T. Okay, first thing is we're going to practice changing percents into decimals for our rates. So if the problem gives you 50%, you're just moving your decimal twice, so it's currently at the back of the 50. You just move it 2 times to the left and it becomes 0.5. For 25%, we're just going to move it 2 times to the left, it becomes 0.25. If you ever do a problem and you look at your answer and you're like, there's no way that can be the case, like it's just a ridiculous answer, go back and check. Maybe you didn't change the parenthesis to a decimal. For 3.3, our decimal is already in between the 3's, so we're going to move it to the left 2 times. So it's going to be 0.033. And for 85%, move it to the left 2 times, 0.85. It's very important that you remember this step. Okay, here's our first problem. The population of Kronoids on planet Drallop was 500 in year 2050. If the population grows at a rate of 20%, oops, sorry, I messed up the screen. If the population grows at a rate of 20% each year, how many total Kronoids would you expect in 2081? So first thing, we need to pick the formula we're going to use. Right away I see this word grows right here. We're going to use our growth formula. Okay, so first thing I need to find is what my initial population was. So I need to plug in something for A. Well, it says that the population started at 500. The 1 always stays there. It's growth, so it's going to be plus. Now I see my growth rate is 20%. Make sure you change that into a decimal. So move the decimal twice, and you get 0.2. The time, I need to know how long I'm growing for. My initial population was taken in 2050, and I want to know how many I have in 2081. So that's 31 years. So that goes up in the exponent. Now you can enter this whole thing in your calculator. 500 parentheses 1 plus 0.2 parentheses, and then your exponent button to the 31. You are going to get out 1,402,426. Okay? So if you have any decimals here, make sure you're rounding. We can't have partial Kronoids. We need to only have whole. Next, we have Sean, who's investing some money. Sean invests $5,500 in 2010 into an account with a 2.6 interest rate. How much money will he have in 2025? So here, he's investing in a bank account. Hopefully, it's growing, so we're going to use the growth equation. Y equals A times 1 plus R to the T. So first of all, we need to start with his initial amount. We're going to plug $5,500 in for A. 1 plus. His growth rate is 2.6%. We need to move that decimal 2 times. So we're going to plug in 0.026. And the time span is from 2010 to 2025, so 15 is going to be our exponent. Now here, we don't want to round to the nearest whole number. We're not talking about Kronoids. We're talking about money. anytime you have money, it's just understood that you're going to round to 2 decimal places because that's how we talk about money. So our answer here, if you plug it in your calculator, is $8,083.01. Okay, now given this equation, so I've given you one of the growth formulas. It looks a little different, but we're going to decide whether it's growth or decay. First of all, if you remember, we usually have our initial amount, which in this case is 4. Then we would have 1 plus some rate or minus to our time. So right now we need to take 0.75 and we need to change it into 1 plus a number or 1 minus a number. Since 0.75 is less than 1, we know it's going to be 1 minus a number. 1 minus what is 0.75? Well, that'd be 1 minus 0.25. So all we're doing is changing that 0.75 to 1 plus or minus a number. Now, I know it's decay because there's a subtraction sign. And I know my original percent was 25%. So 25% decay rate. On your test and quizzes, you'll be given these formulas, so you don't need to memorize them, but after doing your homework, you'll probably have them memorized.